Okay, hello everybody. This is Yves speaking from PowerSys. We will wait a few couple of minutes for waiting everybody to join this this seminar about the JMAG presentation of version 21. Okay, let's wait a few minutes. Okay, hello again, everybody. Thank you for joining this this seminar. Still Yves speaking from PowerSys. So we will start the session now. We have many attendees, so I think we can start. Thank you again for joining this seminar. This is about the JMAG version 21 presentation and introducing of the new feature of this version. The presenter will be Kamal from PWSIM in India. This is PWSIM is a part of the PowerSys group, and this is a subsidiary of PowerSys. So Kamal has a strong education in electrical motor design. He has been involved in many research and student development, mainly in motor design, in the automation and automotive field. He has published many papers in national and international journal and conference like IEEE, and he is also an active member of ISTE and ISCA. So Kamal will present the new feature regarding all those usual topics, I would say. So the different topic will be 3D large-scale problems, so 3D big model, control and circuit, efficiency map, multiphysics, pre-post processing, material, other teachers, and related documents. So Kamal, I will let you start the presentation. I will stop sharing and you will be able to share.
Okay. Yeah. Thank you, Wes, for your great introduction. Yeah. Good morning, everyone. Okay. Yeah. Now we are going to see about the new features of JMAG version 21, which was released during the month of February. As like you was told, so these are all the contents of today's presentation. So we will be discussing about the 3D large scale problems, how the speed is drastically improved in version 21 when compared to the previous versions like version 20.2, and what are all the new features that is added in the control and circuit part, and what are all the features that is added in efficiency map, multiphysics, and pre and post processing, and what are all the changes that is adopted in the material database, and what are all the other features of version 21. That is what we are going to discuss in detail during this session. The first and foremost thing is like how regarding to the 3D large scale problems, how version 21 is far better than the existing versions. So regarding to the speed of the MPP solver for the magnetic analysis, like seeing to this graph, it is clear the version 21 speed up ratio is greater than that of the existing version 20.2 when the number of elements is higher than 10 million elements also. So it is proven that like the speed up ratio of version 21 is greater than that of the version 20.2 when we are running the same model in the same machine. It is proven the speed up ratio is more. So this is the graph which is depicting the speed up ratio for thermal cum magnetic analysis. If you are performing the thermal cum magnetic coupled analysis, there also it is proven that the version 21 speed up ratio is comparatively high when compared to the speed up ratio of version 20.2. So that is the advantage. And regarding the mesh generation, the version 21 pays a greater thing when compared to the previous versions. So it is also clearly shown in the graph that when the number of elements is more above 30 million elements also, the speed up ratio is very high when compared to the existing models for the generation of the mesh. And regarding the processing time in the geometry editor, and after creating the geometry in the geometry editor, we are traversing back to the JMAG Designer window. The processing time of version 21 is far lower than that of the processing time of the existing versions. So from the graph, it is very clear that if we are performing with the solid model in the geometry editor, the processing time for the existing version is somehow high when compared to the processing time of the new version which is released now. And sending back the file to the JMAG Designer also, the same thing holds good. So if the number of parts is going to be above 10,000 or something of it, the processing time of the current version is a bit lower than that of the processing time of the existing versions. That is for the solid model, and the same thing applies for the mesh model also. So opening the geometry editor and sending back to the JMAG Designer also, the thing is holds good for the version 21. And that's all the thing, general thing regarding to the processing speed of the analysis and mesh generation. And now we are going to see about the features that is added in the control and circuit part. So the first and foremost thing is like the macro component, which is nothing but the current vector control component can be directly applied to the circuit window in the version 21. So the current vector control can be easily constructed by specifying only the motor parameters like LD value, LQ value, and number of poles. So current vector control can be easily done in version 21. And regarding to the calculation speed, the speed delay of control calculation is drastically reduced in version 21 when compared to the existing versions. If we take control circuit alone, the speed up ratio is a bit high. If we take electric circuit also into the consideration, the speed may be somehow low, but comparing to the existing versions, the overall speed delay of the control calculation is reduced in the new version 21. And this is the new feature added in version 21, which is nothing but multiple FEM model support study. We have known that with the help of integration study, we can perform this. Maybe the study from multiple domains like magnetic field, or it may be from the thermal domain, or from the structural domain, or from the RT model or circuit model. Whatever may be the thing, everything is getting integrated and we can perform the study. And here in this new version, like how we are going to apply this multiple FEM models with the help of the integration study. So so this is one example. like in the control circuit, we have a FEM motor from a separate study, and we are performing a separate study for the resolver, and both the studies are getting integrated in a single circuit in order to analyze the effect of the motor into this resolver part. So that is what they are trying to convey with the help of this multiple FEM model integration. So the output of the one model is going to be given as the input of the another model, and in the control circuit we can integrate these two models and we can get the output of the model. That is what they are trying to convey. So here they are telling that the eccentricity of the motor is taken as the input for this resolver, so that how the torque ripple ratio is getting affected. So that can be performed with the help of multiple FEM model. Right now, for this, I will show you one function tutorial regarding how multiple FEM model is being done. Okay, hope my screen is visible.
Yes, we can see your screen.
Yeah. This is the function tutorial which is given by JSOL Corporation regarding this multiple FEA study, how the control circuit is being established with the help of integration module. Here we can see that this is the reactor 2D model, and in the same analysis we have another one model called relay model. For that also we have a study. So what we are trying to do over here is we are actually taking the reactor output as an input to this relay model for the excitation, and we are getting integrated with the help of this integration study. In order to do that, what we are going to do is we are using the option called integration model here, and when clicking to the integration model, the integration model is getting coming. So in the project, first we have to go for the create analysis group, and in the create analysis group we have to go for the option called a direct coupling. Why? Because the models are directly going to be coupled. So the output of the one model is going to be coupled for the another model, so we have to take the option called direct coupling. So with the direct coupling we have to select all the options that is given here. So while creating the analysis group, we have to go for the direct coupling option, and we have to select the reactor, we have to select the relay, and we have to select the integration study. So now what we are actually doing is, this is the 2D model of the reactor, and in the study of the reactor I'm going to the circuit, and the normally the circuit will have the voltage to the FEM coil of the reactor and the ground is being connected. Here what we are actually doing is I'm taking the control current probe. I'm taking the this one control current probe with FEA output. That is what given in the first study. And in the relay, what I'm going to do is, so in the relay study, I'm going to the circuit, and in the circuit, the output of the reactor is going to be given as the FEA input. So here what I'm going to attach is, I'm going to attach this control current source. There we are taking control current probe, and here we are taking the control current source. So that is added over here, and the FEA input is given as the feedback here. And in the integration study, what we are going to do is, like in the circuit, we are going to integrate the both. The first reactor model output is given as the input to the second FEA model. So that is how we are integrating it. After running the analysis, we will come to know that how the integration is being done. So here we are going to the results of the reactor and seeing to the results in the graph section, or we can able to see the control current to probe. What is the current that is flowing through it? So this is the current that is going during a particular point of the time. And here what is actually happening is, like, this current is going to be given as the input for the relay model. So going to the graph of the relay, we will come to know that the current, so the current which is produced by the reactor 1.406 is given as the input. So this value is given as the input, for the relay coil. This is how the multiple FEA models is getting integrated. This is how the multiple FEA model is getting integrated. The output of the one model is going to be given as the input of the another model, and with the help of the integration of both the things in the circuit, we can perform the multiple FEA support in the integration study. And this is the next feature which is added in version 21, which is nothing but like in analysis group, if we are creating a speed priority based efficiency map, the RT model of such a study can be exported as an input to the control circuit of the another study we are performing in the same analysis group. For an example, this speed priority efficiency map is going to be given as an input for the another study. There the control circuit is being there. So this is the feature which can be done in the JMAG alone. So for this, I will show you the function tutorial. Yeah. So here also we are going for the analysis group. So in the project, we are going for the create analysis group. Here we are going for the sequential calculation. Why? Because here we are not exporting the output and everything. We are just taking the efficiency map from this model to the next model. So we are going for the sequential selection option. So after taking the sequential selection option, we are checking the both efficiency map study as well as the integration study. So here what we are actually doing is for this PMSM machine, we are actually doing the efficiency map over here. So the efficiency map is created over here. So in the response table, we have to select the option called the phase inductance for RT model export. So after performing this speed priority efficiency mode, the RT model is being exported to the next study what we are using in this analysis. So that option has to be selected over here. While we are selecting this option, the RT spatial harmonic model is being created. So that exported model can be taken into the another study in the same analysis. So that can be seen over here. So going to the circuit, like we may be knowing, this is the PMSM model what we have created in the speed priority efficiency mode in the previous study. There we can able to see it. So here when we double clicking it, we have to specify the efficiency map study and we have to take efficiency map as the option. So the RTT file which was there earlier in the study is directly getting exported into this study. So we can use the RT model of the existing study to the new study. And after running, we will be getting the graphs. So after this is actually the pre-run model. So we may be able to see the graph of the exact control circuit for the RT model which was created in the previous study. So here we can able to see for that entire circuit, like all the values are there. I just take only the control signals ID and IQ value. So from this, it is very clear that the efficiency map RT model can be exported to the another study in the same analysis group, and we can able to perform the control circuit analysis. So that is the one new feature that is added in JMAG version 21. Without going to the RT window and coming back to the JMAG window, we can perform straight away in the JMAG itself, JMAG Designer window itself. And the next thing are like this is also regarding to the speed processing for the JMAG RT model creation for the PMSM model and everything. The speed ratios are drastically improved in version 21 when compared to the pre-existing version 20.2. Here the graph clearly depicts that the calculation time for one case for the creation of RT model of PMSM model is improved when compared to the existing versions. So that is what they are trying to convey here. And that is all about the circuit and the control features regarding to version 21. multiple FEA things can be done, and the another thing is that how RTM or RT model can be given to the next study. And now we are going to see about what are the features that is added in the efficiency map. A very good feature that is added in version 21 is with a single click, we can able to convert our speed priority based efficiency map study into a accuracy priority mode efficiency map. We have three things by which the efficiency map can be created. Out of three methods, if we go for the accuracy priority mode, then the efficiency map what we get will be of more accurate. So that is being done in version 21. By a single click, a speed priority mode efficiency map can be converted into a accuracy priority mode map. So how it can be performed, for that we have a small demo. I will show that. So yes, we have known like this is the partial model we have take for this efficiency map study. Here we know how to create the speed priority based things. So here we have a speed priority study. So in this speed priority study, since it is a pre-run model, we have the efficiency map, and in the map we are going to see the efficiency map. So this is the efficiency map which is created regarding to the speed priority mode. If you want to create the accuracy priority mode, what we have to do is in the speed priority mode, we have to go. So going to the efficiency map, we are clicking here, and in the speed priority mode, we are taking the efficiency map. Here we have an option called create study. We have to hit this. We have to change that to accuracy priority mode or something of it. The title can be changed, and the ranges can be changed as per our thing. Like we may change the values as per our wish, and we have to select the operating points on the NP curve with respect to x coordinate value. And here comes the option. With a single click, we can transform the speed priority mode efficiency map into a accuracy priority mode. We have multiple options over here. We can duplicate the speed priority mode. We can duplicate into accuracy priority mode. And if you want the analysis with RT models and we are entirely converting the FEM coils to conductors, we can go for the very last option from the drop down menu. Here the three-phase FEM PMSM control circuit with the RT model with all the FEM coils is getting converted into the conductors. So I'm taking that option and hitting OK. So the study is getting created. So this is how the study is getting created. So from the speed priority mode, the accuracy priority mode is directly established. So seeing to the circuit now, like seeing to the circuit of the speed priority mode, this is the circuit of the speed priority mode. After giving the options over there, in the accuracy priority mode, we can able to see the circuit is developed automatically. So the efficiency map in speed priority mode is automatically getting converted into the accuracy priority mode efficiency map circuit calculations. If you want to consider and to allow the effect of the eddy current of the magnet can be taken as the FEM conductor. So the magnet is also being taken as the FEM conductor. So here what we are actually doing is like, so this is how in the speed priority mode, this everything would be a coil and now it is being a conductor. And for the magnet also, we are applying the condition of the FEM conductor. And after that, whatever may be the cases we want to generate for the accuracy priority mode, we can go here and we can create as much as equations what we have to do. We can go there and we can create the response table for each and every speed, whatever may be the thing, and whatever may be the parameters we want to add it, we can add it. and expressions what we have created for that, the cases may be generated for the different speeds and everything. And as much as cases what we need, that can be created for the accuracy priority mode. So in this model, 528 cases are developed. So with that, after running to it, we will be getting the efficiency map, which is regarding to the accuracy priority mode. So this is how speed priority mode efficiency map can be easily transformed into a accuracy priority mode efficiency map. Okay. And the next feature that is added in version 21 is like so far in the existing version for the 6-phase induction motor, the efficiency map support was not there, but in version 21, the speed priority efficiency map for 6-phase induction motor is added in the new version. So that is the new feature added in version 21 for the induction motor 6-phase. I will show you regarding that. So this is the 6-phase induction motor partial model. After applying all the conditions and presetting things, like we can go and we can create the efficiency map. So when we go and generate, so this is the application catalog. So here we can change the voltage of the inverter and motor cum generator we are taking into the consideration, and loss factor if we are changing to it. After changing everything, and we have to click OK. So after giving that, the map is getting generated and we can able to see the map. So we have known like the parameters can be changed over here. So in order to precise the map, the right y-axis can be changed with the values so that the map will be constructed accordingly. I have deselected this isolines and everything. That's why I'm getting the efficiency map like this. And as usual, we can able to see whatever may be the thing, like if you want to see the slip, we can able to see the slip. And this is also we have known prior, like whatever may be the speed torque value, we can add the points over there. For an example, for the 750 RPM, I'm giving the torque as 15 Newton meter, and I'm adding that point. Sorry. Okay. So this is how for the 750 RPM and for the torque of 15, the entire loss map is being generated as a pie chart. So 6-phase induction motor efficiency map is being supported in version 21 when compared to the other version which was not supported. So that is the new feature added in version 21. Okay. And this is regarding to in a low speed, the extrapolation function of the accuracy priority mode efficiency map is being there in version 21. Prior to version 21, the interpolation may be there, and in the low speed we are not able to construct the map accordingly, and it is taking more number of calculation points. But in version 21 for 0 speed also, like the efficiency map is clearly constructed with the help of extrapolation function. And this is the short conclusions of the efficiency map with version 21. So we are able to display map values at efficiency map clicks, and we are possible to add cases by settings of the response table creation in an accuracy priority efficiency map study without removing the result that we have seen earlier. Like whatever may be the parameters we want to set with the help of response table creation, we can able to set it. And with the help of pie charts, we can highlight the efficiency map. The entire loss distribution can be easily known with the help of the pie charts. So these are all the improved usabilities of the efficiency map in version 21 regarding to accuracy priority mode and how loss distribution is there with the help of the pie charts. And so far we have discussed about what are the features regarding to control and circuit and the efficiency map. Now we are going to see about what is the feature that is added for multiphysics. And in version 21, like the simulation, like CFD simulation, the everything is being converted into the actual thermal models, thermal resistance models. So that is what, like for the cooling as well as the contact resistances, everything is being converted into the thermal resistance model. For an example, so this is the model what we are actually going to analyze. So the heat transfer from the coil ends is connected to the thermal circuit via the oil thermal resistance. So if we straight away give this values, like flow velocity and the nozzle diameter and the area, the model will be calculating the thermal resistance straight away, and the thermal resistance will be coming into the circuit, and the overall analysis can be done for the efficient thermal modeling. That is one add-on feature of version 21. Here we can able to do the thermal modeling of the motor which is subjected to cooling. So everything is getting converted into the thermal resistance model. So that can be done in version 21. And the convergence issue was there in version 20. But here in 21, this nonlinear calculation convergence is drastically improved with the help of high convergence algorithm. So this is the example that is shown. The contour plot is actually showing the mistress, and the vector plot is actually showing the contact force. So prior to version 21, there may not be the convergence in the part which is shown in the circle. But in version 21, due to the high convergence algorithm, the convergence issue is drastically reduced. So that is one of the feature that is added in version 21. This is related to multiphysics. And going to the pre and post processing. We have the enhanced dashboard functions in version 21. Here, without traversing to the JMAG Designer tree window, often we have the model and study everything under the same analysis parameter view function itself. We have the model and study, both of the things are actually there in the same window without traversing to the JMAG project tree. So that is one of the enhanced feature. And regarding to the magnetization pattern, we can give the magnetization pattern, the center of the magnetization pattern direction and the rotation axis of the circumferential pattern direction. Both of them are actually different. So we can create the center of the magnetic direction, which is different from that of the rotation axis circumferential pattern. And if we apply the magnetization pattern to the one magnet, the rest of the magnets, the magnetization direction can be done automatically. So that was not the case as of now. But in version 21, like if we give the magnetization direction for one magnet, then that is automatically applied to the all other magnets. So that is what they are trying to do. So in order to set the magnetization direction, it has been necessary to set a pattern for each magnet until now. But the magnetization direction of all the magnets can be defined by one pattern in version 21. So that was there. And this is one of the interesting feature added in version 21. Here, what is happening is like when we are going for the multi-stranded coil, so far we are taking entire coil as a single thing and we are creating the FEM conductor for it. But here, if you are taking the multiple strands of the coil, each and every coil can be converted into a FEM conductor. It can be converted into a FEM component. That is actually there in version 21. For this, I will show you the function tutorial. So this is a machine, PMSM machine with a multi-stranded coil. Like there are 4 strands we are having. So this is the pre-model created in the function tutorial. So here what we are actually doing is we are adding the winding and going to the winding area. We can able to see that we have 4 coil regions for the 4 strands. So the coil region 1 comprises of this much conductors, and coil region 2 has to be selected accordingly, and coil region 3 has to be selected, and coil region 4 has to be selected. So this is how we are selecting the winding area. And going to the coil part, we are actually importing it from the set wire template, and with the help of the import option, we are giving the coil pitch and everything. And we are going for the winding 3-phase conductor. And here we have the option separate conductors into separate components and keep parallel connection between coil regions. We have this option. So here what we are going to do is, now I'm not selecting anything, and just I have created the model for this 4 strands. And now what I'm going to do is, like, I'm going to the circuit and I'm weaving to it, and this is the 3-phase and showing the sub circuit. We can able to see that only each phase, the U phase, V phase, and the W phase is taken as a FEM conductors without taking the effects of the strands in the coil. So now what I'm doing is, like, I'm going to the coil region and I'm going to give the option called separate conductors into separate component. I'm creating each and every conductor as a component. If we select this, and when we are clicking OK, then going to the circuit part, and if you are going to see it and clicking here and going to the sub circuit part, so this is the difference. So each the U coil has 32. In one slot it is having 16 conductors, and in the another slot it is having 16 conductors. So put together it is having 32 conductors in each phase. So all that conductors are transformed into a single component. So this is what the feature of taking all the conductors into a component. So with the help of the option that is there in the winding window, we can give the separate component conductors into separate components without selecting keep parallel connection between coils. Assume if we are selecting this also, and I'm selecting that, and we can able to see that in the sub circuit, we can able to see everything is actually connected in parallel. Yeah, just a minute. To the coil and edit. Sorry, maybe I didn't give. Okay. I'm giving OK to it and circuit. Yeah, here we can see that, like, everything is connected in series. All the U phase connected in series, and the components are connected in parallel. So this is what the difference between the two options that is actually there in the winding window. Previously it was like everything is connected in parallel, and now everything is connected in series. So in what fashion we need with that, we can select the option accordingly, which is over here. So this is the feature for the winding editor using wire templates. So this is the feature that is given in version 21. So as we discussed earlier, like for multiple FE analysis and all, we have the coupled analysis. So in version 21, whatever may be the studies that is coming under the analysis group, we can directly change and we can delete or add the studies which is already there in the analysis group. That can be done easily in version 21. But prior to that, what we have to do is, first we have to ungroup the analysis, and we have to create the studies what we want to group, and we have to reset the equations and the objective functions. But that is not the case in version 21. So the time for doing this can be reduced in version 21. So that is the thing. And regarding to the material database, this is the new material data that is added in version 21. The amorphous Itachi metal model 265HB1 annealed and permandur Itachi metal. So both from the manufacturer Hitachi is added to the new material data, and they have deleted the existing material. this is actually deleted. Instead of F2V, now F2V 0.1 mm and F2V 0.2 mm is actually transformed, and this is a new material that is added in the new version. And what are the other features that is going to be supported by version 21 is like one new feature is nothing but how to create the beam coils. And before seeing to it, like here, like the trial and error in the mesh settings is also reduced in version 21. Like version 21 is also supporting for the linear motors and the static apparatus, and we can able to see that the calculation error by developing the mesh is actually reduced in version 21 when compared to the previous versions. So that is what they are trying to tell. The geometry recognition is getting takes place automatically, the element sizes, and it is going to improve the calculation accuracy with the default settings. And moreover, the new version is supporting for the linear motor as well as the static apparatus. And as we discussed, this is one of the new feature, like when we want to accommodate the leakage flux when creating the end winding for the 3D structures. It was quite complex in the previous versions. So the entire size of the machine is getting reduced when we go for the method called beam coils. We are going for the beam coils. In the version 21, it is introduced. With that, we can develop the beam coils, and the overall size of the model is getting reduced, and it is easy to analyze also. So for this, we will go for a function tutorial. So this is the 3D model what we have taken. So for this model, what we are going to do is we are going to create the beam coil. So how we are going to create the beam coil is that, like we are the solid model, we are going to the geometry editor, and for the creation of the coil, we are going to the coil part and we are editing it. Edit sketch and going to the coil template, and as usual procedure what we are actually doing for the end winding preparations, what we are giving the overhang portion, no? The same thing we are actually doing. We are going for the coil template and we are taking the geometry as the radial, and for an example we are going for the spiral type and we are going for the vertex. And here in our model, the number of slots is supposed to be 12 and the number of poles is going to be 4. So we are getting the error that since it is a 4-pole and 12-slot machine, the available pitch should not be more than 3. So we are going to the pitch and we are correcting it as 3. And after going that, we can able to see the outer diameter and the inner diameter has to be varied in order to get the correct winding fashion. So we are going here and we are changing accordingly. We are giving the outer diameter values, and this is known previously, I think, like we are giving the values to each and everything, and we are giving the pull-up height, and we are not taking the bend meter option, and we are specifying the periodic angle. After giving full model copy, we are giving to it, and the entire thing is actually winding is created for the entire model. So this is how we are creating the beam coils very easily. So previously the end winding in the 3D model, no, like we have to correct in order to avoid the intersecting portion. That was the very hard part in the previous versions. But here with this beam coils, we can easily create this overhang portions, and we can accommodate the leakage flux. So one such beam coil is created here. So after creating the beam coil, like what we are actually doing is, in the condition, we are applying the line current option. So after applying the line current option, for an example, to the parts. So in the assembly, I'm only taking the coils. So I'm applying for the U phase. So this is the U phase I'm giving to it. So here we can select the coils accordingly, and we can take the function as the sine wave, and the amplitude of the current will be given over here, and the direction of the current is getting altered with the help of the values what we are actually giving over here. So similarly, for the V phase, we have to do the same with the phase shift of 120 degree, and for the W phase also we are doing the same, and the direction of the current is also being set accordingly. So after giving everything, we are running the analysis. After running the analysis, we are going to see for the vector plot how the current is being flowing. So here we are going to the vector plot, and we can able to see that like in what direction we have stated over here in the line current option. Like in the U phase, in what direction we have applied, in the same direction the current is actually flowing, and in the V phase it is flowing, and in the W phase it is flowing in the direction what we assigned previously. So this is one of the very new feature that is added in version 21, how to create the beam coils in order to accommodate the leakage flux simply without avoiding the intersection errors in the geometry editor. So that is one of the very new feature in version 21. And JMAG Express now supports the parametric analysis also. So multiple values that can be taken into account, and we can evaluate the things. So that is the one thing. And apart from these features, we have another enhancements also. Like we can obviously go for topology optimization using machine learning. There is application note for this. It is actually in the beta version. So that can also be supported in version 21. And there is an improvement in the LD and LQ scenario. Like previously in version 20.2 and all, the most inductive axis is taken as the D axis, and the least inductive axis is taken as Q axis, like that it was there. There was contradictory in that, but in the version 21 it is changed. So the accuracy is being improved here. And as we discussed, the express performance is also being enhanced in terms of the template selection and the time that is taken for the execution and the dimension change and everything that is actually converted, added features of the version 21. So these are all the very new versions features that is added. So going to the conclusion, like whatever the things we have seen is like regarding to the processing speed, the version 21 is paying a very high speed. It is creating the mesh generation in a very fast manner, and in the geometry editor creation and the parallel processing speed, everything is far better. When we do the analysis in the same machine, we will come to know that how version 21 is faster than the previous version. And as we discussed earlier, the current vector control component can be easily done with version 21, and we have seen how multiple FEM model can be done in a single analysis. Like we have seen the example for the reactor cum relay, how the output of the reactor is getting input for the relay, and how such integration is being done in the control circuit, and how the analysis is being made in a single analysis. And we also see an application note for this feature, like how the speed priority based efficiency map is taken as a that RT model is taken as an input for the another circuit input, and how the performance is being done in the same analysis itself without traversing to the RT window or something of it. Obviously, we need the RT module license for performing this. Anyhow, in the JMAG Designer itself, we will be doing by taking the export option of this speed priority mode efficiency map into the another study. And in the efficiency map, this the features that is added is like we have seen that for the 6-phase induction motor, the speed priority mode is added. And the another thing is that how from the speed priority mode, the accuracy priority mode efficiency map can be easily created with a single click by going to the option there. All the FEM coils is being converted into the FEM conductors, and straight away we can traverse from the speed priority mode efficiency map to the accuracy priority mode. And we also have seen that how the thermal resistance components are being added for the cooling and the contact resistances. So that is the multi-physics environment. And regarding the pre and the post processing, now we have the enhanced dashboard functions. And we also seen about how the magnetization pattern can be easily done. And we have seen that for the multiple strands, multiple strands, how we can take each and every component as a each and every conductor as a FEA component, and using the parallel options, and how we can able to construct the entire circuit. And we also saw about the updated material database regarding to the Hitachi material by the manufacturers. And the other features which is supported is what we have seen, like we can model the coils with the help of beams in order to accommodate the leakage flux, especially for the 3D modeling for the end winding creations. And JMAG Express is supporting the parametric analysis, and we can also go for topology optimization using machine learning concept. And LD-LQ is being advanced in JMAG RT, especially for the Sinaram. And there is an enhanced JMAG Express performance also. So this is what the features that is added in version 21 regarding to the control and circuit, regarding to the efficiency map, regarding to pre-post processing, and regarding to the coil and how the processing speeds.
Okay, thank you very much, Kamal. So let me quickly share my screen. Okay, so as usual, you can ask your question using the Q&A panel available in the Zoom panel. Feel free to ask your questions. So we already have some questions. So as a summary, so yes, this video will be recorded and it will be shared with all the attendees. We've got some other questions about low carbon iron. So I don't think we have such material at the moment, but feel free to share any material you would like us to embed it into JMAG. So please share the grade and the material manufacturer. We could try to contact them and to try to obtain material information, material data, so that we can place that into the JMAG material database. So yeah, feel free to ask your questions. Maybe we will stay connected. We'll remain connected a few couples of minutes in case we have some new question. So one question is now about the speed priority map includes stress dependent loss. I think this is possible. You can put some stress dependent material in the material you are using in a speed priority map, but you will have to specify stress using a specific condition in the magnetic analysis, and you will be able to apply uniform stress density. At the moment, I'm not sure this is supporting a kind of coupling feature, or maybe mapping could be made using the multipurpose file import or export tool. This is something that could be checked. So feel free to contact us if you have some more interest in that. I think something could be possible. For sure, you can map or you can input some uniform stress. We need to check about the mapping things if in case you would like to map some non-uniform stress density. But for sure, material stress dependent could be introduced in some speed priority calculation, speed priority map calculation. Yeah, so feel free to ask your question in the panel in the Q&A panel. Yeah, so it seems we've got another question about scripting. But the question is about to come, I think.
Is there a change because one of my script is not working exactly as yeah, we have to check. We will check.
So all the feature in the all the script feature in previous version should be supported by the new version. It should be supported. It should be okay. Perhaps it's possible that it could be a bug. It could be that kind of issue. So we need to check one by one, and maybe we need to check your script. So please feel free to share your script. But of course, it should be supported. It should be okay. It could be a bug. It could be that maybe one feature is changing. But in that case, we need to check it, or it could be a bug or something like that. But in most of the case, it should be okay. It should be supported. Okay, another question is about arranging webinar in next future about efficiency map, different machine types like flux switching machine and other types of machine. Yes, that's a good point. Thanks for your suggestion. We'll try to arrange that. That's very good to have such feedback. This is helping us to know what you really need and what you really want. So thank you. Yes, we will consider that into account and try to arrange that. That's a very good idea and very good suggestion. Thank you. Okay, 2 minutes are remaining, I think, in the schedule. So feel free to ask your question. Okay, so thank you very much for your attentions. Thank you for joining the webinar. Thank you for your questions. I hope we reply to you. If it's not enough, feel free to contact us. Feel free to email us. We could arrange meeting and discussion about any topic, any technical topic. And yes, we will also try to arrange some more webinar dealing on some specific topic as it is suggested. Thank you also to Kamal for your nice presentation. Thank you very much. And yeah, see you soon.
Thank you. Thank you all.
Bye.
Thank you.